Assalamu alaikum. Bismillahirrahmanirrahim. Numericals of thermochemistry. Question number 20. In this question, the standard enthalpies of the formation of carbon dioxide gas, H2O liquid, and methane gas are given, and you are to determine the heat released when 20 grams of methane burns in excess of air under standard conditions. So, strategy to solve this question is that first of all, write the required equation, and required equation is combustion of methane. And you know that when you write the combustion of methane, it means that its reaction is with oxygen gas. So right at the top, as you are watching on the screen, CH4 on the reactant side, gas plus O2, and in order to balance it you may write here 2O2, then arrow, and after arrow carbon dioxide 1 mole and H2O 2 moles. That is the required equation which we are to get after manipulating the equations which are given in the data. So when you get the heat from for this reaction, you will get in fact enthalpy of combustion of 1 mole of methane, and you are to then convert this for the 20 grams of methane, that when 20 grams of methane burns, how much heat is released. So now we come towards data. First is as I have encircled 1, that is equation 1, and that is the carbon plus oxygen gas, carbon and oxygen of course on the reactant sides, and carbon dioxide on the product side. And you know that during the formation of carbon dioxide, 393.5 kilojoules per mole heat is released. So from the data, first equation is formation of carbon dioxide. uh, Second equation is formation of water, and water in the liquid state. So right now the second equation, that is H2 on the reactant side, 1 by 2 O2 also on the reactant sides, then after arrow H2O liquid. And you know that enthalpy of formation of water is 285.85, and exothermic is the process, so negative signs are placed in both these equations for the formation of carbon dioxide gas and for the formation of H2O liquid as well. Now, after writing these two equations in the data, third enthalpy of formation given is the compound, that is methane. So write an equation for the formation of methane. On the reactant side, you write carbon plus 2H2 carbon solid state, 2H2 gaseous state, then arrow, and after arrow you have CH4, that is methane. And enthalpy of formation of methane is minus 74.6 kilojoules per mole. Enthalpy of formation of methane is minus 74.6 kilojoules per mole, as is given in your 2020 edition of the second year chemistry textbook. Now multiply equation 2 by 2. Equation 2 is that of formation of water. When you multiply this with 2, you will get another equation which is written as equation number 4. So, equation 4 is 2H2 plus O2 plus arrow, and after that 2H2O liquid state. And of course you will multiply to 85.85 also with 2. When you multiply 285.85 with 2, you probably get 571.6. This value has been placed along with the equation of formation of water. So 571.61 kilojoules must be written. I have told you time and again that when you multiply any equation with any number in thermochemistry, then you are to multiply its heat values also with the same number. Since when 1 mole of water is formed, enthalpy or heat changes, that is this process is exothermic. In other words, the heat evolved is minus 285.85 kilojoules. Its units are kilojoules per mole. It means that when 1 mole of water is formed, and that is liquid. When I say water, that is of course it is liquid. Now after writing equation 4, you are to add equations 4 and 1, and write, after addition, write this as equation number 5. So you are watching these equations. So equation which are being added here are equation number 4 and equation number 1. Equation number 4 and equation number 1. Equation number 1 is formation of carbon dioxide. Equation number 4 is formation of water that was multiplied with 2 along with their heat values. When you add these two equations, you get equation 5, and equation 5 is carbon 2H2 plus 2O2, carbon dioxide in the products, and 2 moles of water, and you are also add the enthalpy values 393.5 and 571, and both are with negative signs. So here also in equation 5, and the energy or enthalpy value would be negative. Now you are to get methane on the reactant side. For doing in order to get this, you are now reversing equation 3. Equation 3 is enthalpy of formation of methane. So you reverse equation 3 and write this equation, this new reversed equation, as equation number 6. You can find here that in equation number 6, methane is on the reactant sides, carbon, hydrogen are on the product sides, and you know that when you reverse equation, then the enthalpy sign will also be reversed accordingly. So after reversing this equation, the new equation is in the form of equation 6, and after that here on the second you are watching subtracting equation 5 and 6. No, that is not. Since you have reversed, now just you are to add. Kindly correct is add equation 5 and 6. When you add equation 5 and 6, you get another equation, and that is methane CH4 plus 2O2 giving us R in the product side, R carbon dioxide and 2H2O, and you are also to write their values too. Heat of enthalpies, heats or enthalpies values too, and that is also written along with the equation. And this is our in fact required equation. It means that we have reached at the destination. So the energy or heat value that is given along with this reaction is for 1 mole of methane, and this value is given. How much this value is? 890.5 kilojoules per mole. So when 1 mole of methane burns, it provides us with 890.5 kilojoules of energy. Since in the question we have been asked for the heat released during the combustion of or burning of 20 grams of methane, and here we have got the enthalpy for 1 mole of methane, and you know that 1 mole of methane is 16 grams. Here you have two ways. One is either convert 20 grams of methane into its mole, or you may directly solve the problem that 16 grams releases energy how much? 890.5 grams. 1 gram will release, and 20 gram will release. You are to multiply with the amount that is released by amount of heat that is released by 1 gram to uh, 20 grams. Then however, I have adopted second course, and that is convert 20 grams into mole first. You are watching on the screen that mass of methane, molar mass of methane, that is written equal to 12 plus 4, that is equal to 16 grams per mole. So moles of methane that are according to data of the question, divide mass with the molar mass. Mass given is 20 grams and molar mass is 16 grams. So when you divide 20 grams with 16 grams, you get the number of moles of 20 grams of methane, which are 1.25 moles. So 20 grams of methane is converted into 20 grams of methane are converted into number of moles, which are 1.25. Now the third stage of the question. 1 mole of methane liberates heat 890.5 kilojoules, and 1.25 mole of methane will be liberating heat 1.25 into 890.5, and of course negative sign will be there, and finally after multiplication you will get minus 1113 0.125 kilojoules. So that is your answer of the question, that when you burn 20 grams of methane you get 1113.25 kilojoules. Here you are to place negative sign with the 1113.125 kilojoules, because the reaction is exothermic. So dear students, you have to do calculation in this way. First, get from data enthalpy of combustion of 1 mole of methane, then convert 20 grams into moles, which are 1.25 moles, and finally you convert energy that is obtained for 1 mole to energy that would be obtained by burning 1.24 moles of methane. I hope this will be helpful. Thank you so much. Allah Hafiz. Pakistan Zindabad.